Okay, so I will continue where we left off. What we've done, we assigned a dummy variable for x squared equals 8, and then x4 will be equal to a squared, and then we rewrite the function with the dummy variable 2a squared plus 13a minus 17. Then I factor this one out, but a was x squared, so I need to replace back a's with the x squares. So that will be x squared plus 7. So when we're going to do the factoring, obviously 2x squared minus 1 equals 0, 2x squared equals 1, x squared will be equal to 1/2, and x, we are going to have two roots here. That will be 1 over square root of 2 plus or minus. Here we're going to have x squared plus 7 equals 0, so x squared equals -7, and we're going to have x1, 2 here plus or minus -7i square root of 7. Right, so the zeros will be 1 over square root of 2, -1 over square root, positive 1 square root of 2, negative square root of 7i, positive 7i. Now the factored form, this is not actually factored form because it's not in linear forms. Linear forms means that we shouldn't be seeing any x squared, everything should be written in x. So that will be x minus 1 over square root of 2, x plus 1 over square root of 2, x minus square root of 7i, x plus square root of 7i. So in linear and complex roots and with all the zeros. All right, now we're moving to rational functions. So this is a detailed classical rational function problem. Determine the coordinates of holes. Okay, holes happen when we have the two same terms. So then the rational function in simplified form will be 2 times x minus 2 divided by x minus 1 and x plus 3. After we decide the holes, we're going to continue with this function. So where are the holes at? Holes happen at x value -5, but I need to figure out what's the y value. So I'm going to plug in -5 into this simplified form. If I go ahead and plug in -5 here, that is going to make 0 over 0, right? So plug in -5 into this simplified form. So r simplified -5. Let's see what is happening. 2, -5, -2 divided by -5, -1, -5 plus 3. So -5 minus 2 is -7. -7 times 2 is -14. So we're having -2 here times -6. That will be positive 12. So the y value will be, we can simplify it, -7 over 6. So the whole happens when x is equal to -5, y is equal to -7 over 6. Right, -7 over 6. Right, so again, important thing is here, decide where, if there is a hole, and obtain the simplified version. And when you're finding the y value of the hole, plug in into this form. So if you just go ahead and tell me that at x equals -5, there is a hole, you can only get half of the question. So it's incomplete. All right, determine the equations of the vertical asymptote. So we're again looking at this simplified form. Vertical asymptotes happen when at places where denominator becomes undefined, denominator becomes 0, or the simplified version will be undefined. So vertical asymptote happens x minus 1 equals 0, x equals 1, x plus 3 equals 0, x equals negative 3. So these two are the vertical asymptotes. Determine the coordinates of x-intercept. X-intercept means that numerator should be equal to 0. So x minus 2 equal to 0. X will be equal to 2. So the x-intercept will be 2, 0. Intercept is a point, right? Determine y-intercept. Y-intercept is when x is equal to 0. Okay, so we're going to plug that into simplified version. So 2 times 0 minus 2 divided by 0 minus 1 times 0 plus 3. The 0 minus 2 is negative 2. Negative 2 times 2 is negative 4. Here we have negative 3. This is negative 1. This is 3. That's negative 3. So 4 over 3. So y-intercept will be equal to x is equal to 0. Y is equal to 4 over 3. That's the point. Determine the equations of the horizontal or slant oblique asymptote. Now that will require for us to remember what were the conditions for horizontal, oblique, or slant asymptote. Right, so we look at this equation, 2 times x minus 2 divided by x minus 1, x plus 3. Okay, so horizontal asymptote means that x values is going to go very high values, like when x goes to infinity, where is the function going? That's where the situation of horizontal asymptote. So hence the degree on denominator is 1, degree numerator is 1, degree on denominator is 2. So because the degree is higher, degree on numerator is 2, and degree on numerator is greater than degree on, okay, degree on the numerator is 1. Degree on denominator is 2. Denominator degree, numerator degree. Okay, because the degree on denominator is greater than degree on numerator, horizontal asymptote, we're going to divide a number very small number to a very big number. So horizontal asymptote will be y equals 0, because the denominator degree is high. So it will be something like that when x goes to 0. So if we have, let's say, 10 to the power 6 here, at the bottom we're going to have 10 to the power 12. So it will be approaching the 0. The function will be approaching the 0. Okay, that is that. Now here, there's a graph given. From this graph, we will write down a rational function equation from the graph. So let's put some features here. First of all, we have a horizontal asymptote. Oops. Okay, so this is 5, 6, 7, 8, 9, 10. y equals 6. Okay, we do have y-intercept -1. We do have vertical asymptote here, a vertical asymptote here. Okay, so this vertical asymptote will be x equals 2. This vertical asymptote will be -1, -2, x equals -3. Okay, we do have x-intercept here, -2, x-intercept 2, 3, 4, 5, 2. Okay, so let's write it down, this rational function. There will be a leading coefficient we don't know, right? So our x-intercepts are -2 and +2. They should be on numerator. On the denominator, we have vertical asymptotes. That's why we need to have x plus 3 and x minus 2. These are the values that is going to make the denominator 0. So hence, we do have a second degree on numerator, a second degree on denominator. So horizontal asymptote is 6. So if the degrees are equal, we divide the leading coefficients. So I would say that A will be equals 6. But we can also check it by using this y-intercept, A value finding 6. I will leave that up to you to move to the next problem. Okay, so you can find A equals 6 by using the point x equals 0, y equals 2, the same way we have done the polynomial equations. Okay, the last problem. That is a polynomial modeling problem. There was a very similar problem also on the WebAssign quizzes. I think there's a similar problem on the assignment, also on the PowerPoint. So the graph is not given here, the sketch, the picture is not given, but we can draw it together and solve this problem. Let's see. Okay, a park manager has 100 meters of fencing. And to build a rectangular dog park along one side of the existing building, they plan to divide the park in 4 equal sections using 3 interior fences. As shown in the diagram below, there is no diagram, so I'm going to draw the diagram. So we do have a building here. Yeah. So one side of it. The buildings serve as one side of that. So we're going to create 4 equal sections. So 1, 2, 3, 4. So let's imagine that that's 4 equal sections. And we have 100 meters of fencing available. So let me put this picture in a better form. In the exam, you will be given the picture, so that is less of a problem. Okay, so this side is the building. So we don't need the fencing here. Okay, so we don't know how much we're using here. Okay, we don't know what are each of these sections. So each one of them will create a division, a section for a dog park. So we have 1, 2, 3, 4 sections, right? So what we know, only the fencing And the question is, write a function that models the area of the entire enclosure is a function of side B, it says. So it could be side X, it doesn't matter here. All right, so first of all, we have 4y times x. That will be the area. Right? Because this is 4y times x. That's the whole area. Now, we can't use the area consists of two variables. So the area should be coming in one variable. There is a relationship between x and y though, right? Because we have 100 meters of fencing, and the fencing will be done here, here. All this area will be fencing. So we can think about 4y, right, plus 1, 2, 3, 4, 5x, 4y plus 5x is equal to 100. Now we can write down y in terms of x, that will be 100 minus 5x. Then this area in terms of x will be 100 minus 5x times x. So this will be the area as a function of x. So this is the tricky part for this question. The picture will be given, but you need to construct the problem with the variables. And writing this is only going to give you a minimal point, because we want you to establish, can you see the relationship between those two variables, and write one variable in terms of other. So the rest after this blue part is comparatively easier, right? So then area of x will be equal to 100x minus 5x squared, or negative 5x squared plus 100x. That is the area. And we want to have the maximum of the area. So then you can think about, it will be something like this parabola, because it's negative 5. That's less than 0, so we can find the maximum. Well, maximum occurs at vertex, where vertex means hk. H means negative b over 2a. Negative b is negative 100 over 2a, 2 times negative 5, so that will be 100 over 10, right? That will be equal to 10. So when x is equal to 10, you can plug in into equation here. 4y will be equal to 100 minus 50, and that's 50, and y will be equal to 50 over 4, which is 12.5. So this is 10, and this will be 50. All right, so this was the similar polynomial modeling problem that I would like us to know as we're getting prepared for the exam. I try to solve as good as the problems that could be focused for your Unit 3 tests. There are 3 parts of all those videos. I hope you can take time and watch them all. Best of luck.